All right, class, we're going to try this a different way today. What I want you to do is pause the screen and work on these warm-ups, and then come back when you're ready. All right, hopefully for this warm-up you were able to get an answer of a 4. You were able to get an answer of negative 105. This would be chunky plus minus a negative. We're going to put the two together to get negative 6. These are two negatives. They're all on the same team, so there's a total of negative 26 of them. Chunky plus, now they're all positive. It will be 25. This one I threw in there just to see if at this point in time any of you would let that mix you up. But remember, division is just another way to write fraction. So you can leave it like this, or if you really wanted to, you could have turned it into 1 2/3. Some of you may have even turned it into a decimal of negative 1.6, and that is fine. Go ahead here and hit pause and take any questions that you might have. All right, here are the notes from today. Again, I want you to hit pause so you can copy these down into your notes, and hit the start button when you are ready. I'll move this back up for the essential question once it's done moving. Oh my goodness, it won't stop. Okay. Go ahead and hit pause. Copy that down. All right, so we're talking about scale drawings today. Again, very, very similar to everything that we have been doing this last week on proportions and solving proportions. Now we're talking about a scale factor. A scale factor is just another way to write a proportion, to write some sort of increasing indirect measurement of some kind. In this case, we're either increasing something or we're decreasing it. In this example here, it asked us to draw the image of this figure with a dilation center of A, meaning staying at A, leaving A where it is, by a scale factor of 2. What does this mean? It means that I want each segment to be 2 times as long, 2 times as big as what it already was. This is pretty easy stuff. You ready? I'm going to count here. This was 1, 2. If I want it to be 2 times as long, or increase it by a scale of 2, this was 2. I'm going to increase it or times it by 2. So I want it to be 4 long instead. So if I want it to be 4 long, I have to increase it out here. So I'm going to come down here and do the same thing. I'm going to increase it here to be 4. I'm going to look at this one, A to B. This was 1 unit. If it was 1 and I want it to be 2 times as big, I'm going to take it times 2, and that would equal 2. So now instead of just being 1 box, I want it to be 2 boxes. This stays where it is, and I want it to be a 2 here. Next, I know that this was 2, and just like the last or the bottom, I'm going to take it by 2, and I want it to be 4. This has already moved out here, so I have to follow this, but instead of going here, I want it to go up 4 boxes instead. Connect those pieces, and I'll do the best I can here. Oh, let's see if I can continue this on. And they shouldn't be arrows, but due to the time constraints of the recorder, I'm going to just leave the arrows on there for now. And there you go. You have now made this, or used the scale factor of 2 to increase its side. Let's try some other problems, because these would be fairly easy, I think. Okay, here's one with a triangle. Oh, let me go back one thing. I'm sorry. Before we do this one. I have to wait here. One thing that I failed to mention that I do need to point out. Once we get this new image, we have to label its new points. So if this was originally A, it is A, but now it is also A prime from the new figure. We're going to call it A prime. A prime. This was B. This is B's image, so we're going to call it B prime. It's the image of B. This was regular C. This is the new C. C prime. This is D, the new D, D prime. So now I have two different quadrilaterals here. I have quadrilateral A, B, C, D, and I have quadrilateral A prime, B prime, C prime, D prime. Or just the prime, the image of that. Okay. The next problem. Here we go. We have a triangle, JKL, with certain vertices on a graph. So I made the graph here. I'm sorry about the background sheet of paper. Wouldn't let me take that off. With the J vertices at 3. So this would be like, hopefully it'll stop scrolling here in a second. It's having a hard time keeping up with me today. So this J would be, here's 1, 2, 3. Here's 1, 2, 3, 4, 5, 6, 7, 8. This J was at 3, 8. I want to make an image with a scale factor of half. Think about that for a second. What's that going to do to our triangle? Is it going to make a bigger triangle or a smaller triangle? Let's find out. In order to find out where I need to graph my new points, just like the last one where I took each of them times the scale factor, that's what I have to do here. I have to take the value of 3 times 1/2, and I get 3 halves. And I have to take 8 times 1/2. If I did 8 times 1/2, I would get 8 over 2, which is the same as 4. So my new point here is going to be 3 halves, or 1/2. If I did improper, it would be 1/2 over 4. So here's 1/2 and up 4. 1, 2, 3, 4. Okay. How about this next one here? 10, 8. So to find K, I'm going to have 10. Oh, not 10, 8, 10, 6. I apologize. And I want it to be a scale factor of 1/2 again. So I need to take the 10 times 1/2, or half of 10, which is 5, and 6 times 1/2, or half of 6, and that would be 3. So my new coordinate points are 5, 3. So I'm going to go over 5, 1, 2, 3, 4, 5, and up 3, 1, 2, 3. This would be my new K, or K prime, and I forgot to draw my J prime, so let's throw that in there. Last but not least, let's do L. L has points of 8, 2. I want to take half of 8, which is going to be 4, and I want to take half of 2, which is going to be 1. So my new point here is 4, 1. 1, 2, 3, 4, up 1. Here's L prime. So when I look at this now, and I'm going to connect these dots, I got rid of the arrow this time. Did this triangle get smaller? Yes, it did. Does it look about half as small? That's kind of hard to tell because it's a scale factor, so you can't necessarily gauge it that way. But that's how we would solve these problems. Take the scale factor and multiply them. Here's another one. I want you to hit pause and see if you can find the scale factor of 3. So go ahead and hit pause after I scroll this back up a little bit. The points are listed here for you, so you don't have to come up and count them out. Oh, it just won't stop moving. I'm sorry. Nope, thought it was done there. Okay, now it looks like it's done. Here are the values of the points again, just so you can see them. I gave you a hint here, so go ahead and hit pause and finish the rest. All right, welcome back. So let's see how you did. 8 times 3, if we did a scale factor of 3, we should have got a value of 24, and we should have got a second value of 9. Your K values, if I had K is 10, 6, I'm going to do the same thing and multiply them by 3. And I should have had a value of 30 and 18. And this would be K prime. And my L values, I should have 8, 2. So L prime would be 24 and 6. Now I don't expect you necessarily to graph these, but that would be your image point. All right. Now I want you to hit pause, and I want you to go and try the same thing for 1/3. See if you can figure out what the value points would be if we were talking about 1/3. So go ahead now and hit pause, and when you come back, we'll help you out. All right, welcome back once again. Here we go, letter J. Letter J, we had 3/8, and if I'm going to use the scale factor of 1/3, it's going to be less or smaller because I'm making it smaller. So my J prime is going to be 1, and the other value will be 8/3, or if I did that in a fraction form, it's going to be 2 and 2/3, just depending on how you wanted to write that. I suppose you could even use a decimal of 2.6 repeating. K, the values of K were 10 and 6. So then what I could do is take K prime, it's going to be 1/3 of this. So this could be 3 and 1/3, or 10 over 3, with a 2. Those would be my values of K prime. And L is 8, 2. And L prime would then be 8 over 3, which is the same as what's up here, or 2 and 2/3, and 2/3. Again, you can put them into decimals if you want. There would be your values if we use the scale factor of 1/3. Hopefully you got those. All right, sometimes we have to figure out what the scale factor is, and there are easy ways and hard ways to do this. If these were nice and on the box, we'd be able to figure that out super easy because we could just count 1, 2, 3. Maybe here we can count a little bit more. We can count that at